Alright, so Assalamualaikum warahmatullahi wabarakatuh. So I think I need to continue because got uh, someone asked me during class, right? So I try my best to make you understand on ranking test. So I think I need to repeat for ranking test. Okay, don't forget, we know that ranking test is one of sensory evaluation tests classified under preference or acceptance test and can be used to evaluate the acceptance or preference of a sample. Okay, uh, so please remember, under ranking test, we will use the uh, treatment test. The keywords over there is chi-square, right? On the title of the chart, make sure it is mentioned chi-square. Okay, so like uh, hedonic more than two sample. Firstly, we need to determine whether there are a different or not between sample. Okay, if the result shows that there is a significant difference, then only we continue the calculation to next step where we find out the least significant difference, LSD. Okay, where in order to determine which sample is differ from which sample, we use the value of least significant difference, okay, where we need to do some calculation, and then we compare whether the value, the difference that we have between sample is larger or smaller than the value that we calculated, which is least significant difference. All right. So this one actually we already learned in hedonic test more than two sample. All right. So let's say we have, for example, we have calculation here. See, this is the table that you require for calculation of ranking test, chi-square. All right. So this is the example. We already go through actually this situation where the company try to produce new formulation of cake by using 4 different formulation where the sugar content used differently, 20, 40, 60 and 80 gram. All right, they use 20 panelists. If the panel like the sample very much, they will rank 4, and least accepted rank 1. Okay, so as usual, the question will ask you to justify your answer with calculation. You need to indicate whether there is a significant difference or not. All right, so as always, you collect the form, the sensory form, and then tabulated the data into this table so that easier for you to do calculation. All right, so sum up the score. All right, so if you look at here, the score will range between 1 to 4 only. 1, the least accepted, 4, the most accepted. All right, so total up, you sum up, you got 51, 48, 40, and 61. And then we proceed to the calculation. You need to follow the formulation. All right, so this is the formulation given, the formulation that has been formulated by a researcher, okay, previously. So we just follow because this one is the theory behind the software that we use right now. Okay, if you use software, so actually software is shortcut for all this calculation. All right, so 12 must be divided by number of panelists time of number of treatment. So we have 20 judges or panelists for treatment times with number of treatment, which is 4 plus 1, 5. Sum of square of the rank, sum of each treatment. All right, so we total up already. And then you need to square each treatment. like this, 51 square, 48 square, 40 square, 61 square, and then minus 3 times number of panelists times number of treatment, which is 4 plus 1. Okay, and then finally we get 6.78. Keep this value first. Okay, keep this value, and we go to chi-square distribution chart, and then choose 0.05 as the significant level. Okay, and then degree of freedom, we're referring to number of sample we have 4 minus by 1. So we get degree of freedom 3 over here, and the intersection here we got 7.81. So this is the value from table. So usually in sensory evaluation test, when we do the statistical analysis, we always compare the calculated value with the chart value. Okay, so we compare, stated there, if the t value that we calculated more than critical value. This is the chi-square, we referring to the critical value, is more than critical value, then there is significant difference. Since the calculated value, the calculated t value is less than critical value, there is no significant difference in terms of sweetness. Okay, so I'm so sorry, I think I need to adjust first. There is no significant difference here. Wait, there is no significant difference between sample in terms of sweetness. Okay. So actually, your task is done. You just said to your boss, between these 4 samples, even though we use different amount of sugar inside our cake, we already know that the panelists, the consumer, unable to differentiate in terms of sweetness. So I am suggested to you, we can use the least amount of sugar, which is 20 grams, so that we can reduce the cost for this company. Itu contoh keputusan yang kita boleh buat lah. Okay, sepatutnya dah habis, tapi saya nak kena ajar juga cara bagaimana sekiranya there is a significant difference. Okay, sekiranya calculated t value lebih besar daripada critical value, it should be a significant difference. So bila ada significant difference, sama seperti hedonic test, more than 2 sample, we need to find out, okay, which sample is differ from which sample. Okay, so what to do? Don't forget, this is very important, studentized chart. Studentized range chart is very important for us to determine whether there is a significant, which sample is significantly different, because from here we can calculate the least significant different value. All right. Okay, please imagine the same situation, but there is a significant difference. So we need to find out which sample are differ. Mentioned here, below calculation are shown as an example. Since the result obtained from treatment test just now, there is no significant difference, but we just act like we have significant difference, yeah? So we go straight away to calculate the least significant different value. Okay, least significant different value, we will use statistical chart number 6, but as always, don't memorize the number of chart. Memorize what are inside the chart. Okay, we must make sure that it is studentized chart where we have for sample, right? So for sample, and then since this is ranking test, straight away go to infinity. Go to infinity. So we will get 3.63. Okay, the value. So this value will be used in this formulation to calculate the least significant difference. All right. So 3.63, and then you need to times with number of panelists 20 times number of treatment 4 times number of treatment plus 1, which is 5, divided by 12. Okay, and then you got some value. You need to punca kuasa dia. Okay, punca kuasa and then times with 3.63. Okay, let's calculate it whether the value is true or not. 20 times 4 times 5. Okay, divided by 12. Punca kuasa. Okay, 3.46. Okay, yeah, you will get 20.99695 like that. Okay, the value. And then we use this value. This is least significant difference that will help us to show which sample is differ. All right, so please recall back the one that I taught you just now on hedonic scale more than 2 sample hedonic test. So arrange the data according to descending order. Descending. So meaning that the highest value, we start with the highest value and we minus following the order, the descending order, so that we will get positive value. For example, here the highest value 61, which is D, followed by A 51, followed by B 48, followed by C 40. All right, so just now student asked me where we got this value. I'm really forgot just now. Okay, since we already have question, we are referring to the question. Okay, but after calculation, we know that there is no significant difference. Supposedly, we have to stop. But I still proceed just to show you if there is significant difference. Okay? So we use the same data. So after that, like in your other analysis, we always referring to the mean value. So divided with the number of panelists, you will get mean value over here 2.4, 2.6, and 3.1. Okay. So, okay, wait, I need to adjust this one. So finally, this is B. This is AB. This is AB. And this is A. Okay, this is the conclusion that I made. I will show to you later how do I get this conclusion. Yeah. So the conclusion is D is significantly more preferred. more preferred, or you can say significantly different, but more preferred is much better. We can say that because we already do the statistical analysis. If you are not run the statistical analysis by only looking at this mean value without any statistical analysis, you cannot say that the D value is the most preferred as compared to C. Because what? Because you are not run any statistical analysis. Once you run the statistical analysis, you can confirm that the D value, the D, sample D is much preferred as compared to C. Okay, because they are marked by different alphabet. Okay, however, D are not different from A, not different from B, because here got A, here also got A, here also got B. C is only different with D, but not different with B and A, because C got B, B got B, and A got B. All right. So that's the conclusion that you make. If you look at here, this is not the best conclusion. Because what? Because the after calculation, we know that there is no significant difference actually at the first place. But we insist to calculate, so this is the result that we have. Okay, supposedly, if the reading truly show that there is no significant difference, if the reading really shows that there is a significant difference, you might not see double alphabet like this. Okay, it might be A, B, B, B. So it is clear conclusion, D is the most preferred. You got me or not? If you have question, you can text me, yeah? Okay, now, how do I get this alphabet? The procedure is like this actually. Okay, imagine this is the result that we have, the data that we sum up according to the sample name. All right, so from here, and then you need to divide it by 20 to get mean. Okay, but before that, you need to rank first. Rank the highest, followed by A, followed by B, 48, followed by C, and then you divide it into to get mean value. Okay, so look at here. Just now you calculated the least significant difference. Okay, we actually repeat the content that we learn in hedonic test more than 2 sample. If the value here, the difference bigger than least significant difference, there is a significant difference. But if the different value here is smaller than the least significant difference, so there is no significant difference between sample. Look at here. We started with D. Why? Because D is got the highest score, right? So D minus A, D minus B, D minus C, and then A minus B, A minus C, and the last one, B minus C. So after calculating, it shows that almost all, okay, shows a value which is lower or smaller than the calculated least significant difference, much lower than LSD. So almost all shows no significant difference, but we can see only sample between D and C show significant difference, okay, which is 21, but still it's not that big, right? Why? Why this happened? Because at first place, this condition shows no significant difference, but we are insist to learn, so we use the same data. So this is what we get. Okay, so use this information to help you to give mark. Like I said previously, why do we need to give or to mark the mean value with alphabet? Because we want to simplify our analysis. We want to is our panel or our boss or our colleague. Okay, once you present, you need to present in a simplest way after you do all the analysis. So how you want to present to them? Okay, so firstly, mean value here, and then you compare one by one. Between D and A, no significant difference, right? Between D and A, no significant difference. So what to do? If there is no significant difference, you give the same alphabet. Since we start with D sample, which obtain or receive the highest score, so we can give A. We start with A. So 3.1A. This one 2.6A, meaning that there is no significant difference between sample D and sample A. Settle. Okay, the second one between D and B. Between D and B. Bring all the information downwards. Okay, so D and B also shows no significant difference, right? So if there is no significant difference, they should be marked by using same alphabetical number, same alphabet, right? So since we already started with A just now, we want the same alphabet between D and B. Don't look at A. Please don't look at A. Okay, tutup mata dulu. Refer to D and B. So same alphabet, B here and got B here. Okay, so it shows that between D and B, no significant difference. The third situation, between D and C, there is a significant difference. Between D and C, okay, between D and C, there is significantly different. Okay, what is the apa syarat dia kalau ada significant different? Use different alphabet. Okay, use different alphabet. So kita kata tadi D dah ada A dan B. Kalau kita bagi sampel C, alphabet C, dia dah menunjukkan perbezaan, betul? Okay, dia ada A, B, but here C. Okay, kita teruskan lagi. Condition keempat. A, between A and B, no significant difference. Between A and B, no significant difference. Okay, tadi kita dah habiskan, dah sampai sini dah. Bawa turun je semua maklumat tu. Between A and B, no significant difference. Dia dah dapat A, yang ni dah dapat AB. Ada different tak? Tak adalah. Sebab apa? Dua-dua mempunyai alfabet yang sama. Sini ada A, sini pun ada A, biarkan. Okay, seterusnya between A and C, also no significant difference. Between A and C, no significant difference. Apa syarat dia? If there is no significant difference, guna alfabet yang sama. Okay, asalnya kat sini 2.6 A and B sahaja kan? Okay, untuk C pula dia dah ada 2.0 C, dah ada alfabet C. So nak bagi dia sama sebab dia tak ada perbezaan, tambahlah C kat belakang. Betul? Sebab sini ada C, sini ada C. So dia tidak ada perbezaan yang ketara. Okay, proceed lagi. The last one, between B and C, no significant difference. Between B and C. Bawa turun, maklumat tadi ni bawa turun. Okay, asalnya sample B got A only, while sample C got C. Now, between B and C, no significant difference. So what to do? They must have the same alphabet. So sini ada A, tambah je lah dengan C supaya dia sama dengan sample C. Okay, so dia tidak ada significant difference. So finally, you akan dapat macam ni. Sample D dapat A and B, sample A dapat A, B, C, sample B dapat A and C, sample C dapat C. Okay, tengok betul-betul. Sample D ada alfabet A, B, sample A ada alfabet yang sama. So Bermaksud sampel D dengan A ni tak ada perbezaan pun yang ketara. Kemudian sampel B sama juga dengan A, sama juga dengan D, ada A. Sebenarnya tiga-tiga ni tidak ada perbezaan yang ketara. But we have more than one alphabet. Okay, we need to rearrange so that people are not confused. Okay, and then we go here. Sample C only have one alphabet, which is C. And this C also same like in B and in A, but not in D. Meaning that C, B, A got the same alphabet, which is C, and they are not significantly different. Okay, so at the end, to simplify, we know that these three no significant different, these three no significant different. So why not we only use as lesser number of lesser alphabet, okay, is better daripada you tulis sampai Z nanti kan. So kena tengok betul. Why not we simplify like this? Okay, sampel D ada A, sampel A ada AB, sampel B ada AB, sampel C ada B. Bermaksud sampel D, sampel A and sampel B tidak ada perbezaan yang ketara. Sampel C, sampel B, sampel A tidak ada perbezaan yang ketara. Yang ketara hanyalah di antara sampel D dan sampel C. Okay? Saya rasa okey kot kan? So barulah you buat keputusan seperti mana yang saya tulis di sini. Okay? As a conclusion, sample D is significantly more preferred than C, but sample D shows no difference between sample A and sample B in terms of sweetness. Okay? Kenapa jadi macam ni? Sedikit macam confused, seolah-olah macam sebenarnya tak ada beza pun. Betul tak? Tiga ni sama. Kemudian dari sini ke sini sama. Ni dengan ni je beza. Perbezaan yang terlalu sedikit sehinggakan fragment test tadi dia dah cakap dah tidak ada perbezaan. That's why you tak perlu calculate. Tapi we are insist nak belajar juga. So ini yang kita dapat. Sepatutnya sekiranya dekat fragment menunjukkan dari significant difference, you akan dapat very clear statement here. It might be A, B, B, B. Senang. Okay. So that's all. Saya harap video ni berguna. Thank you.